What's up friends, it is time to upgrade my daily driver board. In this video we're going to be installing the MakerX DV6 ESC into my board.
Make my heart beat super fast.
Welcome back to the channel. As you might be able to tell, I'm a little bit excited for this video. Recently, I've been plagued by this nasty overheating issue in this board. Pretty much any hill I would go up started getting a little bit too hot. So in this video, we're going to solve that issue, hopefully. First of all, I'd like to give a huge shout out to MakerX for sending me the DV6 ESC that is going in this board. I think this will be a great increase in performance and reliability. As with the other kit that was sent to me, MakerX didn't pay me to do this review, but I've been a big fan of MakerX products for quite a while now, and I'm hoping that this one should be able to solve the issue that I'm having. Right now, I have a MakerX Go-FOC Retro, which is the 4.12 hardware version of the speed controller that's based on the open source VESC project by Benjamin Vetter. And you know, it's a great ESC for lower amp settings, but as I've ridden this board longer and longer and switched to air-filled tires, it's really started to stress out this ESC. And now, anytime I do a hill, I can pretty much slam it all the way up to 80 degrees Celsius, which is what I have set as the thermal cutoff. So hopefully with this DV6, the heat sink will be able to take this heat better. This overheating issue really does start to become a problem, and it's not necessarily just on hills. While most of the area is hills, and it's really lame to have to take a break halfway up a hill for your ESC to cool down, you can still overheat it on flats. If you're a more experienced e-skate rider, you'll probably find yourself riding over 25 miles an hour more frequently. And for me, I can overheat this ESC in 2 to 3 minutes riding at that speed. And it's pretty lame when you get to that stoplight, you want to shoot off, you full throttle, and you crawl. So hopefully the DV6 will solve my issues. If not, I'll probably have to cut a hole in my enclosure, which is a much less desirable solution. It's about time to install this ESC in the board, but let's go over what you get in the package when you order a MakerX DV6. There are a few things that I love about the MakerX ESCs. One of those is the metal heatsink, which maybe didn't do as well a job as I would have liked on the Go-FOC Retro, but hopefully on this one it will do well. Either way, they're really well manufactured and they look great. You'll see later in some of the close-up shots exactly what the heatsink looks like, how thick it is, and how much it looks like it'll do. Alright, so let's take everything out of its wrapper. This came packaged well in a box with a decent bit more bubble wrap, and I cannot find any kind of damage when I opened up the package. So, got the ESC itself and all of the accessories. Let's pull it out of its wrapper. And there we go. It's definitely a lot chunkier than the Go-FOC Retro with its smaller heatsink. Let's see if I can give you a closer view of that. It's got some real thickness to it. Anyways, you'll see a lot more shots of this in the close-ups. And then we got all the accessories. So in here we have 6 male bullet connectors, a XT90S, 2 UART cables, 2 CAN cables, it looks like 1 CAN cable, and then 2 Hall sensor, oh no, there's 2 CAN cables, 2 CAN cables, a PPM cable, and 2 Hall sensor cables, as well as a micro USB cable for actually configuring the ESC. It would be nice if this had USB-C on it now, but it's okay, what can you do? Alright, so now that we've got all the stuff out of its casing, let's go ahead and start taking apart my board so we can install this. In order to do that, I'm going to have to take off the 10 screws that hold my enclosure onto the deck. And I'll go grab the board right now. Obviously the side we'll be working with is down here by the motors. Screws all the way around the enclosure. So we have 1, 2, 3, 4, 5, and then 5 more on this side. That's not going to stay. Voila. Alright, so we got the board opened up now, and we gotta take out the old ESC. Normally I might write down what order the phase wires were in so I can hook them up properly again on the new one, but it doesn't matter because we're gonna have to reconfigure the firmware anyway. So let's go ahead and unplug the phase wires. Now we can unplug the sensors nice and carefully, and then we've got the receiver. Finally, we'll unplug the meter pro. I've got a couple other things in here. We'll just do that. Got a little bit of desoldering to do, because I tapped in here for the positive lead to be the positive for the lights control. This one I'm not going to worry about, I'm just going to cut off. Actually, I'll cut it off a little longer just in case I want to reuse this. Alright, now the only thing left is this wire, so let me grab what I need for that. Alright. Now the soldering iron has heated up, and we can undo this capped on tape. Go ahead and take this off. Make sure not to flick any solder. There we go. There is the old ESC out. Let's compare this to the new one. You can see we have a pretty significant step up in heatsink size and the actual size of the ESC itself. But the increase in heatsink size is what I'm most excited about, because that is really quite a substantial piece of metal on that new ESC right there. So hopefully this will perform a lot better. I'm already pretty hopeful for it as it is. Hey guys, it's been just a minute for you, but it's been quite a while for me. I've been messing around here in the ESC area, and it really came across to me once I switched this out how much bigger the new one actually is, especially in thickness. And switching cameras here to the other one, you can see that it looks very crowded, and it really is. I had to come up with a unique way of routing the cables, and for this particular installation I'm going to be wrapping the phase wires underneath the ESC and going out here as well as wrapping the XT90 around the side. And the reason for that is because with the ESC flipped around the other way, the sensor wires don't reach properly, and the XT90 is too long and it's just a bad time. Now we'll switch out the bullet connectors to the 4mm ones, and partly because that's plenty of capability for amp output, and partly because the 4mm ones take up a little bit less space. So let's do that right now. Alright, what's up people? I am back. It is a new day. The other day I finished hooking up all of the connectors onto the ESC, soldered those all up, and today we're going to be hooking up the ESC to the actual board and then configuring the whole thing in VESC tool. So I'll toss in a little time lapse right now because it's going to take a few minutes for me to get this all hooked up. Alright, we got all the phase wires hooked up, the Hall sensors connected, and the receiver connected. So now we're going to hop into VESC tool and get this started. So since this is a VESC tool compatible ESC, we are able to use the VESC tool software, which you can download from Trampa's website. That's where I normally get it, or a VESC project. And today we're going to be using an older version because that's what I had on my last board, and I want to do a fair comparison of the performance on the same firmware. So the version you download might be different than this one that we're going to use in the video, but it hasn't changed that much in the interface. So you should be able to still do the same steps that I'm going to do today. Now I've got to power the board on and stick the loop key in. So as you can see on the VESC, or maybe you can't see, it's hard to tell, but there are some blue lights on here that indicate that the VESC is turned on. So now what we're going to do is we're just going to take the USB cable and connect it on one side. And we're going to go ahead and use the Autoconnect function. And on this particular VESC, I think it comes loaded with a brand new version of the firmware. So let's go over to the firmware tab, and the first thing you want to do in VESC tool is just do a read motor configuration and read app configuration. And doing that, it loads everything from the ESC onto the VESC tool so you know what you're working with. And it looks like we have firmware 5.1 loaded, but I want to have 3.62. So what I'm going to do is I'm going to actually load the bootloader first, because that is something you typically have to do on this exact type of ESC. So what we're going to do is just load the firmware, or load the bootloader, and then we're going to load firmware 3.62, and we'll say yes. And now we're going to let it upload the firmware. And then the light should go off on the VESC in a few seconds here. And I can see the green light blinking again, so that means it is finished rebooting. And one way to check this is you can just hit connect again, and it does actually switch to your serial ports when you update firmware. So auto connect again, and you can see that it is now connected, and if we go to the firmware tab, it says 3.62. So now we're just going to redo that on the other ESC. So disconnect, pop it out, pop it in, and go through Autoconnect. Now I said other ESC, this is technically a dual ESC, but in this particular instance, the ESCs are just on the same board, but they are actually separate from each other. So we'll go ahead and load the bootloader again, and then load the firmware. And it's really important to make sure you wait the 10 seconds at least before trying to unplug, because you can brick your ESC pretty easily if you unplug it too early. So now I'll wait for the lights to flash again, and it looks like it finished starting, so we'll try and connect again. Auto connect, and firmware version 3.62. So now we should be good with the firmware. So what we're going to do next is we're just going to make sure everything is red, and then we're just going to do the setup tool, which will automatically configure the motors on both sides. On this particular build, I have 6374 motors, which are considered medium outrunners, and configure the battery. So this is going to be a 24 amp hour battery with 12 cells in series, and this voltage I'll reconfigure later, but we need to put that for now. This is going to be 14 to 55, and the wheel diameter is 145. Now we're going to click run detection, and this will make a bunch of weird noises, and hopefully both sides will configure properly on the first try. Sometimes they don't. And it sounds like both sides are configuring. So what it does first is it measures some of the impedance values, and it puts those all into the configuration, and then it will look for Hall sensors, which hopefully it detected them all properly. It should have. Perfect. So you can see here on the screen now we've got pretty normal looking numbers. I say normal because I've looked at these a lot of times, and it properly detected the Hall sensors. So now we're just going to make sure that they go the right direction, and we don't need that right now. And we'll go forwards and forwards, and both of those are actually going backwards, so we're going to click inverted on each of those, and that is going the correct direction now, and that is also going the correct direction. So now we'll hit finish. So normally you would think we're probably done here, but there's actually a lot of things you can do with VESC tool, and in this instance we're going to mess around with a few of the parameters. So first of all, we'll go into, let's just read everything again just to make sure. It can never hurt really. So it looks like it is going to be giving us about 74 amps per motor as the default setting, but I'm going to set this a bit higher at, let's see, let's set it at 85 for now, and then I can play with it later in the meter app. And negative 85. And then our battery current max, I want to be able to pull 50 amps max from each side of the ESC, so I'll set that to 50. And then minus 12 amps for the battery max regen. And these are just values that I typically use on my ESCs, but I'm specifically setting them like this because I had equivalent settings on the last board. Now, the battery cutoff voltage is something that you can configure too, And for me, I'm going to want the battery to cut off at 3.4 volts, or 3.4 volts times 12 will be the start. So 40.8, which is correct there. And then the end, I want to have it be 3.1 volts per cell times 12 is 37.2. So we're gonna increase this a little bit to protect the batteries and set that to 37.2 volts. And one of the important things to remember is after you change settings, just go ahead and write your configuration, and it'll say that it's written in the bottom there. So now that should be the only settings I need to change right now. Got all the amp settings done, voltage done, cool. So now what we're gonna do is when you actually change settings like this specifically, you have to switch ESCs. So what we're gonna do is we're going to switch over to the CAN bus ESC. So what that did is it switches from the one side of the ESC to the other. And you can't do this for loading the bootloader for whatever reason, but for actual detection and stuff you can. So we're just gonna read again, and we're gonna read again. And you can see here that it didn't save the settings on this other side, which means that we have to change them again. So this is gonna be 37.2 volts, and we're gonna set the current to 85 and minus 85. And then we're going to set the battery current max to 50 and the min to -12. And we are in Hall sensor mode and invert, so that all looks good too. So now we should be pretty good, but we need to make sure we click right settings. Now, theoretically, we would be done, and for this moment, we're going to disconnect from the ESC, and we'll just pull the plug out. And so the interesting thing about UART controllers, which is the ones that have 5-volt ground RX-TX connected in the specific 4-pin mode, is that you don't actually have to configure them on the VESC tool. They just work. I don't know what that reason is exactly, but it just does. But it looks like we're not connecting. Alright, so I did a little bit of troubleshooting real quick, and I figured out the problem. And basically what happened is the RX and TX lines on the receiver were flipped around. And it's kind of weird with VESC-based speed controllers. A lot of them, it varies whether they're going to be transmit to transmit or transmit to receive. And on this particular one, compared to the Go-FOC Retro, I had to actually flip those around. So now we've got the ESC working. So this is great. And now I get to go through the process of stuffing this all in here, and then I've also got to resolder the positive battery wire for the receiver, the positive wire for the headlights, and tape all the phase wires up and connect the meter, and then we'll be good to go. So for now, I will just do another time lapse of me shoving all this stuff in there. See you in a bit. Alright, so I finally finished stuffing everything into this enclosure. And this is probably the tightest that this enclosure has ever been. There's just no space left in here. With the extra layer of foam on top of the ESC and all the different components shoved in there, it's really pretty tight. Hopefully there won't be any major vibrations coming out of there. I think it will probably be fine, but either way, it's all in and configured, and now, since I have the meter connected, I can reconfigure the ESC whenever I want to. So, in the next video, we're going to be recapping what my experience with this ESC has been. It's going to be quite a while before the next one, because I'm going to ride at least 100 miles on it, and after that, I'll give you guys a summary of what I think of the ESC, how it performed, and how it compared to the one that I had before. Hopefully you enjoyed this video, and stay tuned for the next one. Peace out.